Hi, I'm Papia. In this problem, we have to find a polynomial function with real coefficients and that has these given zeros. And the zeros are 2, 2 and 1 plus I. Now, the very first thing you should notice is one of these zeros is not real number. It's a complex number. And yet, we want real coefficients for this polynomial. So we cannot just have these three factors in the polynomial expression. Okay? So how do we know for sure that we'll have real coefficient? Well, recall that if 1 plus I is a 0, then its conjugate is also a 0. And the conjugate is 1 minus I. So that is also a 0 of this function. So we will include both factors for 1 plus I and 1 minus I in the expression. Okay? So using the linear factorization theorem, we know that the function will look like a times a factor for each of the zeros. So for 0 to x equals 2, the factor is x minus 2. Another 0 is 2, so x minus 2 will be repeated twice. And then for 1 plus I, the factor is x minus of 1 plus I. And 1 minus I is also a 0, therefore we'll have another factor, x minus 1 minus I. Now, you know that this problem can have many correct answers. Well, we can plug in any a value here and you will get different functions for that. So for simplicity, let's just pick a equals 1. And we'll get one function that we want. So by plugging in a equals 1, we just have x minus 2 square. And then these two factors, I'm going to rewrite these factors so that when I expand, when I FOIL, it'll be easy to FOIL. So what I'm going to do is, notice we have x minus of 1 plus I. So I'm going to distribute the negative sign and I get x minus 1 minus I for the first factor here. And the second one, I'm going to do the same thing. So it will be x minus 1 plus I. Now notice that you can group x minus 1 in both factors. The reason I'm doing it, now these two factors looks like this is a quantity a minus I times a quantity a plus I. So this can be combined together as a difference of two squares. That's why I'm doing it. So this turns out to be x minus 2 square times difference of two squares, a square minus I square. So you will have x minus 1 square minus I square when you combine these two or FOIL. Okay, so let's expand x minus 2 whole square. That's x square minus 4x plus 4. And the other factor, expand x minus 1 square. That is x square minus 2x plus 1. Now notice I square is negative 1. But we have a negative sign in front of it. So it's negative of negative 1. So this is another positive one. Right, one more step, x square minus 4x plus 4 times x square minus 2x plus 2. And now we will FOIL and we will find our polynomial function. Okay, so let's see. X squared times x squared, we have x to the 4. Then x squared times negative 2x, so negative 2x cubed. X squared times positive 2, so plus 2x squared. Then use negative 4x the same way. Negative 4x times x squared, negative 4x cube, negative 4x times negative 2x, so plus 8x squared, negative 4x plus 2, so that is negative 8x. Then continue with this 4. You have plus 4 times x squared, plus 4 times negative 2x, so negative 8x, and 4 times 2, positive 8. Let's combine the like terms together. Okay, notice that there's only one x to the 4, so keep it as it is. Then let's see how many x cubed terms we have. We have a negative 2x cubed and a negative 4x cubed. And that combines to give you negative 6x cubed. Then let's see the x squared terms. We have 2x squared, 8x squared, and 4x squared. So 8 plus 2, 10 plus 4, that's positive 14x squared. Let's look at the x terms. We have a negative 8x here and another negative 8x. Combine them, that's negative 16x. And finally, one constant term, positive 8. So this is the final expression of a polynomial function with all real coefficients, note, and the zeros 2, 2, and 1 plus I. Thank you.